So LeetCode has this top interview 150 questions list. I have done the first 3. So let's continue and see if we can go through all of them within a few months. All right. I've recently started to learn Python, so I'll be coding in Python. This is a medium problem. So similarly to this, except that now we're keeping each element at most twice instead of just once. And we want to do it in place with constant extra memory. Okay. So I remember for remove duplicates from sorted array 1, we were traversing. We had 2 pointers and we traversed the array once. And that was enough to do it in place. So now we just need to keep each element twice. Well, I'm thinking that we could have one additional counter that just counts each time we have a new element. We count how many times it's appeared, and if it's over 2, we just skip to the next. Yeah, let's try to implement that and see if that works. Okay. Let's have a counter starting from 0. We have 2 pointers. One is pointing at which position we are at right now, and the other one is pointing at, so for this example, one would be pointing at where we should add the next element. So when we are here, for instance, one will be pointing here and the other one will be pointing there, and these will skip. So one pointer, let's call it index, and the other one, let's call it position. Or just use I. Just use I to go through the array. Let's see. How will we traverse this? Oh no, I forgot to start the timer. Okay. It's already been 4.5 minutes, so we'll add that later. Okay, let's focus. I don't remember how to traverse this. It was a long time ago I did the last one. So it fits this. Well, so let's say we're here. If it's the same as the last element and the counter stays at 2, then we move on to the next. Otherwise, we put that 2 here, and then we increment the position and move to the next element as well. Let's see how we can start from the first one. I mean, the first logic that we have is if otherwise okay, so when we start, they are the same. They're both at index 0. Then we move on to the next. Okay, let's adjust this as we go. So we move on to the next one. They're all at 1. Now we move on to the next as well. Counter is at 2, and this is not the same as last. Maybe we can start this at 1. Okay. Oh my god, it's not going well. Okay, let's refocus. Okay, we start at 0 and counter and I starting at 1. Okay, first round they are the same and counter is at 1, so we increment everything. Now position is at 1, I is 2, counter is 2, and they are different. So what do we do then? So these are different. What do we do in this case? Can reset counter to 1, and we move these along. Okay, we will refactor this later. Okay, so counter is 1 again. Now I is here, position is here. So these are the same. So then counter becomes 2, I is here, position is here. Okay, so this is where we need to do something. So it's the same, and counter is 2. So what do? We just increment to the next. Okay, so now we have, now I is here, position still here, counter is still 2. We move on to the next, and now we have position here, I is here. It's not the same. So in this case, we want to move this 2 to this position. And we will do that. So they are not the same. And counter is 2. So you want to put this one here, positions this one here, and then we wanna move all of them. And reset counter. So now positions here, and we have index I pointing to this. So this part. So I is pointing to 3. So 2 is here. We wanna, and counter is at 1. So where was this case? If they are not the same, we just move along. Not the same. So, okay, there was this case. They're not the same. I'm thinking that we only need this. Alright, so if they are the same and we already have two of them, then we just move on to the next one. If they're not the same, then we will put that in place and move along every index and reset counter. Otherwise, what's the last case? Last case would be if they're the same, but we only have one of them, then we just move on to the next. Okay. So what about the end? Okay. We will return +1. That's how many elements in the end. Let's try this. Oh, interesting. Okay, so one positions here, we have I here, we moved to this place. Okay, and next one is 3. They are different again. So what do? We moved 3. We should move 3 to here. Oh, okay, I see. So 3 is moved here. And then they all increment. So the last one, what happens with the last one? Last one. That's same as position, and counter was only at 1. So that's why it wasn't moved. So if they are the same and counter is at 1, this should happen as well. Okay, let's try that logic and then refactor later. Or actually not sure if this is Python syntax. Okay, that's wrong. If they are the same and counter is 1. So these didn't get moved. Oh, it's because in this case we need to increment the counter as well. Okay, well this needs refactoring. Definitely. So we'll move that and increment counter. Okay, so that's the red logic. We need to refactor this whole thing. Alright. Oh, that took so much more time than expected. It's okay, it's gonna get better. Alright, let's refactor this. So we have this logic. So for all of them, we are gonna increment I. So let's remove that. Oh. Wrong answer. Actually, I'm not quite sure. This is the right syntax. Right, that's not the correct syntax. Um, okay, if I is the same as position, we'll have 1. So here, right here, that's we only had 1. It's pointing to that. Okay, next one. This is where it goes wrong. They are the same. Oh, I see. I see. It was incorrect to remove that logic. Oh, look at that. I have already solved this back in February in C#. Huh. I don't even remember that. So what we need is this. It's not really much refactoring though. There's gotta be something better. Okay, so one thing I can take out. If it's the same element and we already have 2, we will continue. If it's same element, we only have 1, then we will replace that and increase counter. If it's not the same element, we will replace and reset counter to 1. Otherwise, we just increase the counter. What is this case then? So this would be, I mean, we have same element counter 1 or 2, and we have different element. So I don't think we need this case. And we will increase the precision. Okay, that seems to be much better. So we do not need this. So we have when they are the same element, counter 1 or counter 2, or they're not the same element, then we'll replace and increase counter. No, reset counter, and in the end we increase our precision. Alright, I think that's compact enough. Let's look at some other solutions. So this is my solution in Python. Okay, that's surprisingly short. If k is less than 2, so it's doing one update, and so this is like my, oh, so they are not using any counter. Oh, I see. They completely skipped using a counter, so they're just always looking at the last 2. I see. Okay, so for all the numbers, for the first 2, they're just gonna stay the same, okay? And then for the third element, 1k equals 2, if it's not, okay, so if the third element is not the same as the first one, so they're looking at the last element. If it's different, then we oh, okay. If it's different, we put it there. So like this. So these 2 stay put, and now we look at this. K is here. If it's different, we put this here. Next one, different than 0, we put it there. This one is different than 1, nope. Then we just move on. Is this different than 1? No. Moving on. Is 2 different than 1? Yes. So we put this 2 here. So k was still here. And then afterwards, I suppose k, increment k. And then is this different? Then we put it there. Okay, let's see. Let's see one more time. Right. Oh, sorry. Wow, this is really smart. I am so impressed. This is so smart. Okay, let's implement that. So all we need is a k, and for all the numbers. Oh, this I is a little confusing to me, so I'll just name it number. If k smart. Okay. Okay, this video is long enough. Okay, it will get better. I'm gonna get better. So, time and space analysis. So we are only traversing this input array, input list once. So the time complexity will just be O of n linear, and is the number of elements in the input. And the space complexity is just constant because we're just using some pointers, and we're doing this in place. So linear time, constant space. Okay, I will look at some more solutions later, but this video is long enough, so I'll see you next time.